Hello everyone, welcome back. Recently, I did something really exciting. I sat down with Harry and we started learning HLSL from scratch. The goal was to just learn how to read HLSL, but I think we went and we kind of developed something really interesting really quick, which kind of can help you overcome this hurdle with HLSL of like not learning something cool and resembles results really quickly. And I think we did that pretty well because we kind of covered the block structure for HLSL and how to read it. And we also did some texture scrolling and texture distortion and some lerping as well. If you want to watch that, it's at the very last of the recording. But I hope you're really gonna enjoy this. If you haven't watched my podcast with Harry, I really recommend that as well. I'll also leave his information in the link description below. So without further ado, I really hope you enjoy that video. All right, I'll leave you to it.
Nowadays, shader graph is the most common way to create shaders. But as I was telling Jack, like learning HLSL is like immensely useful. You can very easily go from HLSL to shader graph. You know what's going on under the hood. You can learn even more or do like even more complex stuff with HLSL. Basically, shader graph abstracts a whole lot of stuff. And with HLSL, you can just do pretty much everything. In case you don't know, Unity basically has like a system for shaders other than shader graph for like handwritten shaders, which is called Shader Lab. It's like a very well-known name for that system because you don't really see it anywhere. But the idea is that you have like a file with code, with shader code, that is encapsulated within some Unity stuff that Unity uses to communicate with the engine, right?
Yeah.
So I'm gonna make like the simplest shader I can find here. So this is 6.3, and I chose this version because they finally added templates for URP HLSL shaders. So
what does that mean though, templates?
So before, when you were going like through project and like create and shaders, there was like a unlit shader, surface shader, and those were actually like file templates from the built-in pipeline.
Yeah.
So surface shaders, for example, don't even work in URP.
Yeah.
So
Okay.
They actually used CG, which was like the previous language that shaders were using instead of HLSL. They were not up to date with URP. So finally, now we actually have like templates that are up to date with URP.
Yeah.
So the most common ones that you would use, that would be like the European lit shader and the SRP bleed shader. Basically, that's for like post-processing effects.
Oh,
like
gotcha. All right.
Yeah, that gets applied in the whole screen.
Yeah.
Because like the process of actually like doing a post-processing filter on top of the screen, that's called bleeding, right? So we just want the unlit shader here. I'm gonna call it like HLSL demo or something.
Got it.
And we can actually make a material out of this the same way that you could do it with shader graph. I can just drag it on the material, or that's also a quick way. If you right click on a shader and you go like create material, it will create a material that uses that shader directly.
Oh, okay. Cool.
Yeah.
That's a cool trick.
Yes. Quick shortcut.
Yeah.
So I'm gonna add a little quad because quads are the easiest 3D objects to see like shaders on. You know what? I'm gonna set it to be at 0, 0. There we go. I'm gonna apply that material. And now we can actually take a look at the shader itself. So we could do that either by opening up the shader or like through the material, we could just go like edit here.
Ooh, and that is the moment where beginners be like, all right, I'm done. I don't want to do this. Yeah. I have no idea what's going on. So let's try to demystify this moment, please.
Yes. Yeah. Yes, that would be the main goal for today because, yeah, this is the most scary thing. And that also applies, like, if you're familiar with coding, some of that stuff might seem familiar, but even in that case, it will still look very weird because there are like 3 different languages in here.
Yeah.
And that's because of that shader lab thing I mentioned.
Yeah.
Like, I'm not going to go into it yet, but like the actual shader, the actual HLSL language is this part.
Oh, it even tells it like HLSL program, and then it ends with end HLSL, right?
Exactly. Yeah, that signifies that this is where the actual HLSL code begins.
Ah, got it.
The other stuff, they are for Unity to know, and I mean we'll go through them a little bit. So first off, I mean this whole thing is encapsulated inside like a little block called shader. That makes sense. It's a shader.
Mm-hmm.
Just so you know, this is kind of structured, and like the syntax is very similar to like lower level languages like C and C++.
Why do you say lower level?
Those are called lower level because they are closer to the machine in terms that they have direct access to memory, and you can very much brick your computer if you write their own code.
Ooh, okay.
Something that you wouldn't really be able to do with like Python or something, you know, like more
Got it.
higher level as they call it.
Higher level. All right, all right. So it's like a bit censored, basically.
Yeah. This is basically like C defines like blocks of code with like these braces here.
Mm-hmm.
So these need to match. So, you know, you open something here, you close it here. By the way, I'm using Rider for writing code, especially with shaders, because it also has like very good autocomplete, and you can also like even go to definitions of stuff inside the shaders. Very useful, highly recommended.
What are definitions? Just real quick to explain that.
So, for example, this here, like by default, this shader is using this, is calling this function. All right, I'm not gonna get into what that is or what it's doing, but it's a function. This is included by Unity. This is not like a standard HLSL thing. It's a Unity function.
Oh,
if I hit F12, I can actually go and see what it's doing. With his,
okay.
Yeah, doing some math and calling some other functions, which I can also check, and so on and so forth.
Okay, so that's what it helps this writer, basically.
Exactly, yeah. VS Code or like other text editors don't really have this level of intelligence, basically.
Got it. Thank you.
All right.
All right.
So yeah, we're opening up blocks of code with like these braces. And the most important thing is, at least for HLSL inside here, is that all the lines need to end with a semicolon. Well, not exactly all of them, but basically the statement ones, those that are like on their own, like this one, or like the code that we will be writing, they are all end with a semicolon. It's a way for HLSL to understand that, okay, this is a line, it starts here, ends there.
Got it.
Cool. So the first block here that we have, these are called the properties. And if we check those out, these might look familiar because we actually saw these names out on our material.
Oh, they're
base
like
color, base map.
They're like parameters in shader graph, basically.
Exactly. Actually, it's exactly that. I think they're also called properties in shader graph, right?
Let's
parameters in Unreal.
Okay. I think so. Yeah, basically.
Those are the ones that are exposed on our materials, and they need to be here so that Unity knows that, okay, I'm going to expose this kind of property. You can have different properties like colors, 2Ds for like textures. You can also have floats. So let's actually make one just to see that.
Float is basically a number between, like, it could be 0.0002 or something like that.
Exactly. It's a floating point precision number. So that means that it's not an integer. It's not like 1 or 2 or 3. It also can be like 3.3 or something.
Yeah. So it's really good with like colors, for example, because they have like endless values between each other.
Exactly. It's to also like interpolate and also do like,
exactly,
blend between like a color or something.
Yeah, absolutely.
So this is the identifier or the reference ID basically for that property. It's going to be used internally in our shader. We're going to see how in a little bit. This is the name that's actually shown on our material.
I just love the effect that is happening when you're typing stuff.
Oh, yeah, of course.
It's so rewarding.
Yeah, of course. Yeah, I need to have like little confetti when I'm writing. And yeah, let's set that to be like 0.5 by default, something like that.
Okay, so when you say
So
equals 0.5, that means you're setting the actual
the
value
default
that it
value.
will have, the default one. Yeah. All right. Cool.
Yeah, exactly. It could be whatever we want. It's just like the default one when you're creating the material.
Yeah.
So if I actually now go, if I actually go here, I can see that I have my value here exposed 0.5.
Yeah.
Cool. And now we're moving inside the shader, which is inside the block called subshader. Because of reasons, they are very obscure reasons. You could have like multiple subshaders and select based on, or it might actually even be a remnant of older shader days. But still, this is where the shader actually lives. This also lets Unity know some information. So if the object is opaque or transparent, for example, this is important to actually understand the ordering of the of when the object will be rendered.
Perfect.
Right. This is because we are in the universal render pipeline, and this Unity uses this in order to differentiate between different shaders and to actually grab all the objects that use a shader for that pipeline and render them in URP, stuff like that. Very internal use stuff. And now, these are like the interesting stuff here. We are into HLSL. Well, first off, I mean, it might be worth mentioning what this means. So when you're rendering an object, essentially you're making, you're getting like a pass for to draw the pixels that this object occupies on the screen, right? An object can actually have multiple passes, which are inside the same shader. This is something that you can see very clearly, and let me actually do it real quick. So let's make a little cube, for example, and another cube so that it can actually get the shadow from this cube. So little tangent here, but I think it's worth mentioning. I'm gonna open up the game view. I removed my game view. Okay, here. Cool. Yeah, we can see our objects here. I'm gonna remove that for a little bit just to show this. So I opened up the frame debugger.
Whoa.
It can be a bit, no, don't be scared. It's actually pretty cool. So this is the pass that renders all the opaque objects.
Got it.
Right? So this actually renders both our cubes. It's a batch because they have the same material, yada, 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 but basically they're doing the same thing. And we can actually see that they are rendering with the default lit shader, right?
Yeah.
And it also says that it's using pass forward lit 0, so the first pass of that shader. Now, if I actually go here on the draw light shadow map, this is the pass that draws the shadows from the main light. We can actually see that here, for those objects, so our cubes, it's also using the lit shader, but this is using pass shadowcaster 1.
All right.
So it's using a separate pass inside the shader, the same shader, that is used for the shadowcasting.
All right. Okay.
That random tangent is just to show that a shader can have like multiple passes so that an object can be rendered in different occasions by different systems.
Okay, that's cool. All right.
Yeah, just something quick and small.
Is that like a transparency thing, or is it something you would need for other purposes?
It's something that the engine can leverage for a whole bunch of reasons. So, for example, as we saw for shadow casting, it can be for registering to the depth or the depth normals pass. It could be for motion vectors, or it could be something that you could leverage, on your own with like an injection in the render pipeline. So that's that gets very, very deep very fast.
Yeah,
but
saying injection sounds very deep.
I know, right? But yeah, that's just to show that this is like a single pass, all right?
Yeah.
And that's just to render pixels on our screen.
Got
It's
it.
the main pass, basically, all right?
Yeah.
So that means, by the way, that we don't have a shadow casting pass. And this is why this quad will never cast shadows.
Oh, okay.
It
So
would
it's
need...
sorry to interrupt, but it's not as easy as like enable cast shadows in like shader graph.
No,
Ooh, okay, got it, got it.
no, yeah. That's a problem with basically unlit HLSL shaders like this, is that in order to get lighting and shadow casting and shadow receiving
Mm-hmm.
and depth writing and a bunch of other stuff,
Yeah,
you have to write plenty of code. It's a bit annoying.
yeah,
And the cool thing is that Unity has like a lot of, stuff you can call to make things easier.
yeah.
But you still have to do very, very things very explicitly.
Mm-hmm. Mm-hmm.
All right. So moving on. This lets Unity know what it's going to use as a vertex and the fragment shader. So for people who don't know, generally there are plenty of different shader types, right? The most common are the fragment shader or the pixel shader, which is what outputs actual color on the screen.
So that
And
is a
then you
2D
have
shader, right?
uh, I wouldn't define it like that. It essentially just takes an input and outputs a color.
So
You can see
basically,
that it's...
the reason I said 2D is because it literally shows on the UV of the screen, right? So it's kind of like translating the 3D world vertex shader into the 2D screen, correct? To pixels, basically.
Kinda, but it might be even more helpful to not basically restrict it like that. Because, for example, you could use a fragment shader, pixel shader, to write a color, but to output it onto a 3D texture.
All right. Yeah, but it's still using the UV coordinates, basically, right?
Yeah, or any sort of data.
Yeah,
UVs are the most common, but yeah, any sort of data.
Yeah, all right, got
it. So what confused me a lot initially with shaders, because like I came from a programming background, right? And I know that in C, for example, you have a main function that gets called like from the program, and then any other function gets called from somewhere, right? And these here, they just kind of hang out and they do stuff, but nobody actually calls them, like nobody's doing like anything like vert, something like that, like calling a function. That's basically what this is called, right? So this is what happens here. This lets Unity know that the vertex shader lives within this function. This block here defines a function. And the fragment shader lives within this function. So like those names don't really matter. I might as well call this pixel. But I would have to change it here as well.
I love that.
And it would still work.
Yeah. I love that you explained that, because it never really clicked for me what those two things were. Those two blocks, right? But it's nice to know that it's calling upon them, but it's also getting the
yeah. It needs to match. And that also means that if you want to use like other types of shaders that are not available in shader graph, for example, a geometry shader, I'm not gonna go into that rabbit hole, but just so you know, this could be like geometry, and you could have another method that includes like all the geometry shader stuff. But basically, this is how you could do that.
Cool. And if like people want to go and learn the types of shaders, is there a video we can link to like show them that?
Good question. I mean, they are all over the place in some diagrams that show like some different stages in the render pipeline with like the tessellation shader and the hull and domain shader, that kind of stuff. Cannot think of anything in particular, but I do have a tutorial on geometry shaders that it's pretty much the same because they haven't really changed. So we can link that.
There's also a really good video from Branch Education, how do video games graphics work, and it's very edutainment in that sense. I'll link that one as well down there, because it shows you all the shaders and their processes in an animated way. I think I'll link you that too, because you will quite enjoy it.
Yeah, that sounds really cool, really interesting.
Perfect, let's go.
Yeah, after that we have this include, which basically takes all the contents of this file, of this core HLSL file, this one here, and for all intents and purposes, you can assume that it just copies and pastes all the code that's in there in this area, like and, exactly that.
Yeah, and those are tools, right? Like rulers or like hammers and, you know, screwdrivers that you're using, right? So you're calling upon the tools that Unity uses for calculations and stuff to use them afterwards. Cool.
Exactly. So for example, like Unity has an internal structure for what constitutes like a texture. So if I didn't have this line of code, the shader wouldn't work because it doesn't know what texture 2D is or what a sampler or.
They're literally not defined, basically.
And, yeah, exactly.
Yeah, and by basically calling in that code, you're like taking a cable from that code, right, and sticking it in your server code or whatever, and you're including
exactly, and you have access to all of that stuff.
Yeah, awesome. I love that.
Yeah. These, by the way, that they have this little hashtag, which nothing else has. These are called preprocessor commands, I guess. Basically, that means that this is code that will be run before this whole code is compiled. It's pre-compiling, I guess.
Yeah.
Basically, it's like meta coding, like code to say something for your code. If that makes sense.
Yeah.
Next up, we have something really interesting. These are, first off, these are structs, right? So basically, you can think of them like buckets or like sets of data, basically, that they have specific data. So this bucket has like a 4-dimensional vector and a 2-dimensional vector inside them.
Okay.
So it's basically handy in order to actually have, you know, like to have them in one place, right?
Yeah.
And we have two. Sorry, yeah.
What is it exactly doing? It's I can see that it's taking the position data from the world, right?
No, it's not from the world. It's actually a bit more interesting.
All right, I can see S there. OS, I guess something screen.
It's actually object space.
Object space. Okay. All right. Let me know about what's happening here. I would love to know.
Yeah, of course. So these structs, basically, or this data, actually, they are what are called interpolators. All right. Scary word, but you might actually have seen it before. And I will show it real quick with a custom unlit shader graph.
I just love that you're switching between the shader graph and the HLSL, because that's, I think, the way that education should go, basically.
So if you go here in the Vertex group and you do a little space and you search for interpolator. Wait. Wait, where are the...
I see.
There it is, custom interpolator. Okay.
Yeah.
I don't know why I couldn't find it before.
I think you clicked outside of the vertex. That's what happened.
Maybe? Yeah, okay, I get it. All right, so we have the custom interpolator. So this is something that you've seen here, and it's not called like this here, but that's what it is. So an interpolator sounds fancy. It essentially means that you have data going from one stage of your rendering to the next stage of your rendering.
Oh, like a pipeline of production, right?
Exactly.
Station to a station? Yep.
Yeah, and they actually like interpolate, like very literally.
Yeah.
Because for example, and I'm going to open Krita real quick.
Let's do it.
Doing all sorts of teaching materials here. And I haven't opened Krita here.
Well, basically, the stream is a test, right? If it works and people actually like it, then please let us know if you like it. We're going to do more of this, and we'll see where it goes. Because it's very educational. I feel like HLSL is something that is not taught the right way, or not taught as much, at least. in a live settings, and like, okay, let's sit down,
Yeah.
let's see what people who maybe don't have experience in coding will ask, right? Like me, for example, things I would ask you might not come in as natural as to it is being like taught through a course. All right, we're ready. Let's go.
Yeah.
Hell yeah.
So here's the thing. I'm gonna play specifically with like the quad we have, right? So we know that the quad has like 4 vertices.
Yeah.
Right? They go like this.
Mhm.
It also is like 2 triangles, so it's doing this, but we don't care about that.
Yeah.
All right. So we also know that, for example, let's say the UV texture, right? The UV coordinates of a mesh, right? They start from here being at 0, 0. They go all the way here to 1.1. Like on the X and Z. Like here it's 1, 0. Here is 0, 1. All right.
The middle
So
is 0,
these-
5, 0.5, 0.5. I had to point that out.
Yeah, but actually that's what I was going to talk about, because like we only have these 4 vertices, right?
Yeah.
With these 4 sets of data. How do we know that the UV here, for example, is going to be 0.5, 0?
By using a ruler, I would imagine. In the real life, I would like put a ruler from the camera to like the vertice and calculate how much that is or whatever. How would you do that?
Yeah, but like, well, you know this one, you know what this one is.
Yeah.
You know what this one is.
Yeah, it's
so,
half.
The shader knows that it's in the middle, so what it's doing is interpolating the data from here to there.
Ooh.
And therefore knows that it's in the middle, so it's like 0.5.
Okay, all right. That is happening in which shader? In the fragment or in the
This
vertices?
essentially happens from the vertex stage to the fragment stage.
Awesome. Yeah, that makes sense.
So that's why this sort of data is called an interpolator, because it interpolates from the previous stage to the next stage, and basically takes all the in-between values. Because again, we only have like these 4 vertices here.
Yeah.
Like the vertex shader is being run 4 times, once for each vertex.
Exactly.
But like if this quad was actually like filling up the screen like this, it would be like 1980 pixels by 1080 pixels.
Yeah.
So like almost more than 1 million or something.
Yep.
So the fragment shader gets run more than 1 million times. The vertex shader is run 4 times, once for its vertex.
Wow. Okay, so that fragment shader is way more expensive in that sense.
Yes, it is.
All right,
Yes,
finally. Finally, I got that explained.
good takeaway from here. If you can do something in the vertex shader, do it there.
Yeah. And make it interpolate so it doesn't make as much work, right? If you interpolate,
the interpolation basically happens automatically.
Automatically.
Right? That it's what's happening when it's going from the vertex stage to the fragment stage, the pixel stage. There's an in-between step, which is like the rasterization step. It's not a programmable stage. We cannot access it. We cannot modify it. It is what it is.
It is what it is. Yeah.
It is what it is.
Yeah. Okay. Cool. All right. Let's dive into it. We have 2 interpolators, right? Float 4 and a float 2, or is it just float 4?
It's the float 4, which is for the position. So like that's the object space position.
Yeah.
And the float 2, which is for the UV coordinates. These are exactly actually the coordinates that we saw here.
Yeah.
Right.
Yeah. And the first one is taking the location of the vertice, right? Not all of them, because it's doing a pass through the 4.
Exactly. So these are in object space position.
Yep.
So we can also very easily assume, I'm gonna erase those. We can also not even assume, we actually do know, because this is a quad, that this is the center of it, right?
Yep.
And we know that it's a 1 by 1 square.
Yeah.
So we know that this position here, for example, the position in object space, so for this mesh, it's going to be at minus 0.5, minus 0.5, and 0 because it doesn't have any depth.
Yeah.
And that here is like 0.5, 0.5, 0, and then all the other values.
Yep.
So these are the object space coordinates. When you model the a mesh, it has like these coordinates for each vertex so that it knows that, you know, this is there basically. And no matter how we actually move, here we go. No matter how we actually move this, rotate it or scale it, the object space position doesn't change. It is relevant to the object itself.
Got it.
But what happens is that we want to actually see it in terms of our wall space, or in terms of our screen space, actually.
Screen space, actually,
Yeah, so what needs to happen is that it needs to go from object space to wall space, from wall space to the camera space, so that it knows how far away it is in terms of the camera. And then it also needs to go from camera space to clip space, which is when the perspective is being applied and all that stuff.
Okay.
Not going into that because matrix math are scary for everybody.
Let's not go there.
We will not go there. But basically, this is what happens here.
So basically, let's just imagine the shader being a factory where you have literally like a pipeline. First pipeline is saying this wall that we need to paint is 1 meter wide, 1 meter height, and then it takes those information right through the vertex shader. The guys who did the math, they make it, put it on paper and pass it through the fragment shader, right? And now the fragment shader is actually the one painting that wall on the screen, correct?
Exactly.
Cool.
Exactly. It's very much a pipeline going like this.
Yeah.
And this is where we actually get that data from the mesh. And while this is some weird uppercase stuff that we don't see anywhere else, this here define the nature of that data, like from where we take them and here where they're going basically. These are called vertex streams.
Oh, streams. I love that. I love that term
that
you used there.
And they have some very specific names that, though we don't care about the names here, but we do care about those here, right? So these are called UV because they are UV coordinates. We know that, but might as well call them text coord or whatever. But the fact that this here, scary big word, it's called text coord 0, that means that we get that data from the first UV channel of a mesh, because as you probably know, 3D meshes can have multiple UV channels. Yeah. So if we wanted to take the second UV channel, that would be text coord 1.
Awesome. I was asking myself how to do that, but now I know. Thank you. Awesome.
Yeah. And another cool fun fact, since we're like combining stuff you might have seen, if you make a little particle system, right?
Yeah.
And you scroll down here on the renderer, there's this term again, custom vertex streams. I don't know if you've used that, but essentially it allows you to pass custom data to like a specific vertex stream. And then there are those terms again, text coord 0. So I could like add, for example, like an H% or something that would go to text coord 0.z.
Ooh, cool.
So that's a random tangent again, but just to show that
I love those random tangents. Like, how do I learn more about those random? Is there a book to get those random tangents? Is that a book you're writing?
No, it's just like years of fragments of stuff you learn about, and then they suddenly click.
Yeah. So I love that. All right.
We're just gonna have to do lots of streams, I guess.
Yeah, let's do it. I love it. All right, let's go.
Yeah. So this signifies the object space position. This signifies the UV coordinates, and these here are basically the stuff that we are passing onto like the fragment shader, which is now it's called HCS instead of OS. This stands for I guess homogeneous clip space. Basically, it's like the final position pixel space, screen space position for the pixel. We basically don't mess with that. If you want your object to show up on screen, don't mess with that.
Don't mess.
You can do something like, let's add 0.3 and see what happens. Now it's like it's offset now. You can see that it's like not
I
centered.
love that. Yeah, it becomes its own
But
like.
it's also inconsistently off center. So
I can see where that could be an effect, right? If it's a portal, you want to have like the back parts doing different things. You know where animations used to do like layers just to fake the distance. In games you see that a lot. So yeah, that could work too.
Yeah, but like you can see that it's like all over the place, like in different axes, different sides. So it's like
Yeah.
you could do that with a different way, but basically
Yeah.
we just leave this as is,
Let's
not
not
touching
mess
that.
with this. But it's nice to
Not
see
touching it.
if you did mess with it, what happens. Yeah.
Yeah,
I love that.
there is actually a very interesting use case for that, but it can get messy, and I'm not gonna go into that right now.
Let
But
us know,
basically,
guys, if you want to see the messy thing. Yeah, in the comments.
it's actually very, very fun. I'll give you like a little hint. It's about being able to paint on objects,
Ooh.
like directly on like their
Like
textures.
decals?
No, it's like actually like drawing on them.
Ooh, all right. Now I'm
Yeah.
excited. Now excited.
So here's another interesting thing. So these are basically the data we are getting from the mesh, the data we're getting from like the vertex states. This here, we've seen those terms before. Those are the ones we have here, right?
Yeah.
These are the, basically we're passing those reference IDs, those
parameters.
Yeah, those parameter IDs basically.
Yeah.
From the properties inside our shaders, so that way it can use them. So it's not enough to just declare a property here, like we did with the value here, right?
Yeah.
We also would need to pass it inside the shader. So that way the shader can actually read it and all that. And these names need to match up from here to here. And that way Unity will know to send that data.
So what you're trying to do, if we go back to the shader graph, right, you're creating your parameters, you're hooking it up with the like the node thing into the right thing, right? But you're doing it with code, so that's what's happening, right?
Yeah, and a lot of that stuff you can also like see in shader graph as well. So we named that property value, right? And you can see there's also this reference, this underscore value.
Yeah.
It's exactly what we did manually.
Yeah. And then you basically hooked it with code, just like you would take the thing and hook it in shader graph. And that's what we've been doing now. All right, cool.
Exactly. And this is how we pass those, so we can use them. Like this is the value that we added. This is like for a texture. It has like this kind of weird syntax, which maybe not now is not the best time to go into it, but yeah, this basically is how you declare a texture inside the shader. And you also need like a sampler. This is basically a little structure to signify how this texture will be sampled. That means if you want to use like linear interpolation or point filtering, which by the way, these are all stuff that you can see if I have like any texture here, any texture whatsoever. This is a very clean project. Let's take a random noise texture. So these are stuff you see here, the wrap mode, the filter mode. Those are basically what are included in this sampler structure, basically.
That's a complicated thing, I would say, the sampler.
It sounds complicated, but it's not so much. It basically like it gives directions to the shader how to sample the texture.
So I have to imagine it like the painter in that factory, right? Or would you say
maybe the specification of like the
color?
The paint.
Yeah. Okay.
Yeah.
So the quality assurance, like, or the person with the job description, basically, like, hey, this 0.5 area needs to be green, so just paint it green.
more like use this brush to paint that color. Like
all right.
It's a bit like even higher level.
Okay, cool.
But yeah, whoops, lots of stuff. All right.
Mm-hmm.
These are.
Go
Sorry,
ahead.
yeah.
I want just to say, like, it can have more complex functions because you mentioned the brush, and I was thinking, like, what could be a brush in HLSL? And the first thing came to my mind was, like, operations, right? Like some type of calculation, some type of animation. That could be a brush, right?
Yeah, I guess.
Metaphorically. All right, let's keep going.
Yeah. These are some more properties. They are inside this C buffer start. It's getting a bit hairy here. Long story short, these need to be here to make the shader buds. So, for example, if I actually go into the shader that we're writing here, right now it will say that it is not. Oh, it is SRP compatible? Okay, whatever. If it was saying that it's not SRP compatible, SRP butter compatible, sorry, it would indicate, it would say that this property needs to be inside that block here.
Yeah.
That's very meta stuff, whatever.
I wonder what SRP means, actually.
It's for the scriptable render pipeline.
Oh, all right.
The overall system that Unity uses now for URP and HDRP.
Oh, okay. All right. So it's the base of the URP, basically.
Exactly.
Oh, okay. I didn't know that. That's good to know.
Yeah. And finally, now we are inside the actual shaders, right? So the vertex shader is getting an object of the type attributes, like of this here, which, as I mentioned, has like the information of the mesh.
Yeah.
Like right now, it has the position and the UV. If we wanted the normals of the mesh, for example,
float 4,
as easy as you probably
think.
I mean, it would be a float 3. We don't really need the fourth component here. So normal, and the big uppercase word is going to be normal.
Oh, okay. All right. That's easy.
Yeah, that's easy. Can you imagine what that word would be for the tangent vector?
Tangent.
It will be still tangent.
Cool. That's awesome.
Yeah.
Let's keep it simple.
Yeah, I mean, it makes sense. Again, like Rider also auto-completes those as well.
That's beautiful.
So you can see that you get like all the text code. These are other stuff, not for this case.
Is that the place where you would put things like height map, specular, like, or is it
no? These would be properties of the material, so they would go like here
up
and
there.
then redeclare it here.
Oh, okay.
This is where you would get like all the data that you would need to use from your mesh.
Okay, so you were talking normal vector, not normal texture, right?
Yeah, sorry. Yeah, didn't specify. Yeah, that's the normal vector of the
mesh,
actual mesh. So like,
which is
that vector here.
Is it on the vertices or is it on the middle
of the face? It
is on
the vertices.
Really? Okay.
No.
I thought they were always in the middle of the... All right, that's good to know too. No. Awesome.
Yeah, those that are in the middle of the face, actually, they end up being... Okay, that's it.
They're like the dot product of all of the 4, right? The one in the middle.
Actually, when you're doing it on the face, so that's something that you could do for like not a smooth shading, right? More like a low poly look.
Yeah. All right. Low poly.
Right.
Yeah.
So if it's actually like this, you end up having. Let's use this color. You will end up having this vector being on this face and this face and this face. Sorry, in this vertex and this vertex and this vertex.
Yeah.
So basically, when you have like a normal that is the same in one face, you essentially have the same normal in all 4 or 3 vertices of that triangle.
Yeah,
basically.
But a sphere would be different, right? Like if we have a sphere that is made of polygons, it would be like each quad on that sphere has like pointing downward, right? So it shades smoothly.
So yeah, it would basically interpolate between those normals and have a smoother.
Yeah, but that's only if you have shade smooth on, right? If you have a shade, what is it called? The other one, shade flat. Then it would literally put the normals like that to a snap, and it would look like the plane you just had before.
Yeah, and the interesting thing about that little fun fact, shading smooth is actually less expensive than shading flat, because what's going on with shading flat is that you end up having a different normal for this vertex when it's for this face, and a different normal for the same vertex for the other face. So you end up having double the normals.
Ooh.
Basically double the vertices almost.
So it's more performant to just shade smooth everything, basically.
Yeah, actually
that's cool. That's cool. All right, that's good to know. I would have thought the other way around, but yeah, I guess more details.
I know, right?
Yeah. That's cool. All right.
Yeah. So, so the vertex shader is taking all that data from the mesh, and it's outputting a varyings. I'm not quite sure how to say this. Varyings, I guess. So yeah, an object of this type where it outputs the screen space position of the pixel. Again, we don't mess with that. It's not screen space, it's clip space. It's a different space. Whatever. Let's just call it clip space. We don't mess with that. But basically, we need that to see things on our screen. And here we are also playing around with our UVs. Basically, we are assigning them from the vertex data.
Yeah, exactly. Yeah.
Here, it's also doing this transform text. That basically means that it's applying the tiling and offset of the texture here.
Yeah. Which is now the base map, and you could even literally see the base map parameter or property in there.
Yeah, I can actually, I can also like it here. Ooh, so in order to actually apply the tiling and the offset, it needs to do this transform text.
Oh, so if we put a time function here, it could even lead to it having panning effect or something.
Potentially, let's see. So if I add the time.y here.
Ooh, hey, we did it! But why is it going on y and the x? That's the thing that I don't get right now.
Oh, because I'm adding
the whole thing.
Dot y, to the whole UVs.
Oh,
if I float 2 and only on the x.
Okay.
Now it will just go on the x-axis.
That's very nice to know. So basically, if we could replicate that real quick in UV in the shader graph, how would that look?
So that would be we would need a texture. So I'm gonna add one here. I'll call it texture something. So this needs to be sampled, right? So we're going to do like a sampled 2D texture. And here it takes these UVs here. It needs some UVs. Basically, exactly as we added the time to those UVs. This, by the way, the logic of this is more close to doing this. It's going to have the same effect, but instead of adding them in the vertex shader, I'm adding them when I'm sampling the texture.
Ooh, so are they happening in the fragment shader now?
Yeah.
But isn't that more expensive, Harry?
It's just one addition. It's honestly not a big deal.
Okay, we need to go more deep into this, because the way you explained that the fragment shader is more expensive, I was thinking maybe this is now more expensive, but it doesn't seem to be like it. All right, let's go back to shader graph.
It's negligible, like simple addition and math like that. It's easy, and like we will do lots of more complex stuff in the fragment shader. So,
all right, that's cool.
At this stage, honestly, don't even worry about it.
Cool.
We can say that it's still working. So the idea is we added time, like a float to our UVs, with the time being on the X component. So
that's like
I'm going to take UVs.
I think you need the coordinate, right? The tiling and offset tiling and offset node.
It's actually doing the same thing. I'm going to do it even more manually to get it closer to the shader.
All right, cool, nice.
So we're going to add a vector 2, right?
Yep. Which will allow inputs, yes.
I'm gonna take the time.
Multiply
that. I just added here. I mean, if we wanted to make it slower or faster, we could multiply it with something.
Sure.
Now I'm just adding it plain.
Cool. Yeah.
And now these are the UVs that I'm using.
All right.
So
It's
I
not hooked
can,
yet. It's not hooked into the
yeah.
base
I'm
color.
going to change the shader here. Gonna use the same. Oh yeah, it's not hooked in the output also.
In the
Yeah,
base
that's what you
map.
meant.
Yeah, all good. Base color.
Yeah.
Here we go. We have the
And
same effect.
exactly, and it's you can also see how these translate to the same math, right?
Yeah.
So this is the sample node. This is the sample function. It takes UV coordinates like this, same as the node here, and we just added the time to the UVs, and that makes it work exactly as it does in like the shader graph.
Awesome.
So yeah.
Yeah, now we can read it. Now we can read the HLSL a little better instead of it just being gibberish. Now knowing like what each step is doing in there. All right, so how can we make this? What do you still have time that we can do maybe one more variation of this? Or it's 74. Yeah, go ahead. Sorry.
Yeah, maybe like a small one. Maybe just tweak this a little bit.
Yeah, let's do it.
Okay. So let's see. So we let's bring in that custom shader here. There we go. What we're doing here is that we are sampling that texture, and it's actually doing this panning here by modifying the UVs, right? Let's I don't know, do something kind of weird. Let's grab the UV coordinates from here. So let's just return in.uv.y just to see this gradient here, right?
Oh, so you did the split from the UV that you would usually do in shader graph, right?
Yeah, exactly. Yeah. The split with HLSL is much easier. You just do like dot.
Literally, like, yeah, because you're separating the. Yep, I love that.
That component.
Yep.
So much faster, right? So we get this little gradient here, right? Let's do some funky stuff with it. So we can, let's say, multiply that by, I don't know,
base
10.
Map? By 10, okay. Yeah, that would add more contrast now. That would make the black more black, right? And the white more white.
Yeah, basically the white more white, but that's way too white. But what I want is to put it in like a sine function.
Okay.
So this will give us
cool.
wavy.
All right, that's nice.
Yeah, and this also goes to -1 here because it's a sine wave, right? Sine waves go from -1 to 1.
Exactly. You can add +1 now and it will be gray, right? Oh, multiply. Interesting.
The better way to remap it to the 0, 1 is to multiply first by 0.5 and then add 0.5 again.
All right. Okay. How would that look now?
So now it's going like from 0 to 1.
Yeah.
Right?
Yeah.
And we can, I don't know, maybe use that as a lerp.
Okay. All right.
So let's make the color, I don't know, lerp between the original color, so that the thing that we had with the texture, right?
Yeah, it's called color. Yeah.
Yeah, and I don't know, a deep red for regions.
Yeah,
so
for
that would be like a float.
1 0 0
0 0
1. Because it's still alpha.
I mean, it honestly it's opaque, so
it's opaque. True.
Wouldn't matter if it's 0.
Yeah.
But yeah, and we're gonna use that sine thing as the final parameter for lerp. Maybe in a separate video or something, we can talk more about like the lerp and the sines and all that because they're very interesting.
Yep.
But basically, we're going like from the original color we had from the texture to a red color. We're interpolating between those things using that sine pattern we saw.
Yeah.
So now it's doing this.
Wow.
Why not? And we can even animate that sine wave by adding time here again.
.y. Now it will go like an old TV, right? Scanning through it.
Actually, yeah. Okay, yeah, it's pretty slow. So let's. Yeah. So now.
Oh yeah.
Like moving.
Oh
like
yeah.
a big a big part of like shaders in general and doing like fun shader effects is just stacking, just layering.
Yeah, you literally
So
started with the UV, and then you added the sine, then you got the waves, then you started, manipulating the waves a little bit, then you animated the waves, then you kind of lerped between the texture and the color. I love that. I love how it works.
And yeah, you can just like mix and match as much as you want. So for example, I can try adding that sine wave to the UVs.
That is exactly why I want people to learn how to read HLSL. Oh my god. So you literally are... That's a fun one. That's a fun one.
Yeah.
I love that one. It's kind of like watery, right? A little watery, would you say?
Yeah. It essentially is what you would do also with like a little bit of displacement. Like maybe this is a bit too much. So if I actually multiply that by something small like 0.2 or something.
Yeah. Yep. That will make it, yep.
Yeah.
I love that. It's kind of like
also moving, so it's, yeah.
Like a stylized shore waves, if you will. Like you could really take this places, basically.
Yeah.
Let's take something like more clear. Oh, hell yeah. Now we're talking.
Yeah. Wait, I have lots of noise textures.
I mean, that's... that would make us... what is it called? Like a technical artist. A technical artist is like your style is your textures.
Yeah.
Pretty much.
Yeah, and like all the noise textures, like just build a library of noise textures, like the go-to advice.
We can go even a step further if you still have like 5 minutes. We can take that 0.2 and make it into a parameter that we can tweak in real time.
Oh yeah, this can actually be our value. I mean, we have it here already, so
yeah,
why not?
Why not? True. Yeah.
Why not?
Yeah.
And by default it's 0.5. We can go nuts on this or reduce it.
Oh wow. This makes me happy. This makes me so happy. And this is only on one axis, right? So if we applied that distortion on the X and the Y, then we could even have something more like a C wave.
Actually, this right now is on the X and Y. That's why it's also slightly weird. Because I haven't added it on like a float too. So now it will be just on the X. So now you can see it going like...
Nice. Huge thank to Harry, of course, for sharing his knowledge and making HLSLs just that much approachable. Remember, guys, we are all in our journey in different stages. It's like climbing a mountain, right? If you're at the beginning and you see someone very advanced at the end of the mountain, just know that it's just time and progress, that you can't go all the way to the top of the mountain on in one day. We all have to go like there, and that's what I try to do with those streams. I try to humanize the process, and I hope you really kind of learn the basics. Of course, there's a lot of courses out there that teaches HLSL. This video is more like an appetizer for you, maybe to get into that, but enough of that. Like, if you actually want to see more of those, let's learn with someone, or if you want to see part 2 of this, please let me know in the link in the comments below, and like this video. It really helps with YouTube and kind of the motivation, the purpose of like doing those in the future. And if you haven't joined the Discord from Harry and joined the Discord from the generalists, you will get updated on all the latest stuff. This channel is still small, so subscribe is really appreciated. All right, cheers. See you in the next one.